electric charge. This section is about forces and motion. In this section, we'll look at distance, speed and acceleration, and more about forces and motion. First, distance, speed and acceleration. A useful way of showing speed is on a time and distance graph. A straight line on the graph means that the speed is constant. The extra distance travelled each second is the same. The steeper the line, the faster the speed. The actual speed is the slope of the graph, the distance divided by the time, in kilometres per hour or metres per second. Here's a question about interpreting a time and distance graph of two cyclists, green and red. Describe the journey represented by the green line. What average speed was it travelling at? Describe the journey of the red cyclist. How did you get on? The green cyclist sets off at a constant speed and covers 70 kilometres in 3 hours. And that's it. The average speed for the journey is the distance divided by the time. Remember, speed is in kilometres per hour, so that's 70 divided by 3, 23 1/3 kilometres an hour. Pretty good for a cyclist. The red cyclist sets off at a constant speed and travels 15 kilometres in 3 hours. The graph then levels off. That means that the distance travelled is not changing with time. It's standing still. In fact, the graph shows that the red cyclist stops altogether for 4 hours. A long lunch, maybe. The downward slope of the rest of the graph means that the red cyclist returns towards the starting point, travelling the 15 kilometres in 2.5 hours. If something doesn't travel at a constant speed but gets faster and faster, then its time-distance graph looks something like this. Accelerating is the word for getting faster and faster. Decelerating is the word for getting slower and slower. Acceleration and deceleration are the rates at which the speed is changing. There's another way of showing acceleration on a graph. That's a time and speed graph. What was a curved line on a time-distance graph now becomes a straight line on a time and speed graph. Here's a time and speed graph of part of a typical bus journey. The straight line from the start up to A means the speed of the bus is steadily increasing with time. It's accelerating at a constant rate. The steeper the graph, the greater the acceleration. The actual acceleration is the slope of the graph, the change of speed divided by the time. The horizontal line from A to B means that the speed of the bus is not changing over time. It's still travelling, but at a constant speed. A downward sloping line means the bus is slowing down. It's decelerating. The horizontal section from C to D is where the speed of the bus is not only not changing, but it's come to a stop. Then off it goes again. It's important to be sure of the difference between a time and distance and a time and speed graph and what they're telling you. Watch out for them in your exam. That's the end of the section about distance, speed and acceleration. Next, some higher tier forces and motion. In the Foundation Physics programme, we saw that you need an unbalanced force to make something accelerate or decelerate. If you double the force, you double the acceleration. If you double the load, that's the mass, you halve the acceleration. A mathematical way of saying that is that the acceleration, A, is proportional to the force, F. but inversely proportional to the mass, m. That's known as Newton's second law of motion. Those two can be combined to give an equation. Acceleration a equals f divided by m, or the way it's most often written, F equals ma. Force equals mass times acceleration. That's it for forces and motion.